This article, which reported on discoveries in late Cretaceous sediments in North Dakota, added fuel to my interest in dinosaurs and why they no longer are cohabitants on the Earth. They are at present only represented by their descendants, the birds. This talk will lead us through the who, what, where, when, and why of dinosaur extinction. Paleontologists have identified 5 major extinction events in the past 541 million years, since life on Earth first developed hard parts, and we could observe their changes through time, their successes, but also their failures. The first extinction event began about 100 million years ago, about 100 million years later, about 440 million years ago. I was trained as a geologist and micropaleontologist. Paleontologists study fossils, be they bones, shells, footprints, any features in sedimentary rocks that indicate the existence or behavior of life in the past. Micropaleontologists are not small scientists, but those who study fossils of microscopic organisms, be they plant or animal. I have a bachelor's degree in geology from Queens College and a master's and doctoral degrees from Florida State University. I worked for service and research labs for Texaco Oil Company, remember them? I initially served as a micropaleontologist in Los Angeles and Denver, and upon moving to Houston, I became a reservoir geologist, determining the depositional environment of rock formations that could serve as a source for petroleum or serve as a reservoir for oil and gas. My master's research was a study of early Permian conodonts. Found in exposures in Kansas. Conodonts are tooth-like parts of marine creatures that survived on Earth for about 400 million years. These were their only hard parts, and they were all a millimeter or so in length. Maybe the biggest was about 3. The animals that bore these elements were apparently eel-like and carried these tooth-like parts in some sort of oral cavity. We found them useful for determining the ages of sedimentary rocks. They're easy to get out, and they can also tell us how deeply a particular formation had been buried by their color. My dissertation was the paleographic distribution of high-latitude late Cretaceous calcareous nanoplankton, something everybody should know. Right. These are commonly referred to as coccoliths. Coccoliths are small single-celled algae that are still around today. They are best described as globes of overlapping perforated calcareous plates. The photos at left are as how they appear on a powerful light microscope. The image at the right shows how they look when studied with a scanning electron microscope. Actually, those are some samples that I studied for my dissertation. There were times in the past when there were extensive, long-lasting coccolith algal blooms. And when they died, their skeletons rained down to the seafloor. You are quite familiar with them. Lithified deposits of these accumulations are called chalk. But first, a brief commercial, as Fred has already said. Once I left Texaco and moved back to New York State, I met D.L. and Lee and moved to Albany. She introduced me to the craft of storytelling. We performed together for adult audiences as Frank Lee speaking. Now, before we can talk about the demise of the dinosaurs, we need to briefly review the 4 prior extinction events. There is a varied list of likely causes for these extinctions, including extreme climatic changes, widespread volcanism, meteorites and asteroids, changes in composition of the atmosphere and the oceans, and some of these processes may have served as a death knell for the dinosaurs themselves. These times were not a pretty picture, for between 70 and 96% of the species alive prior to each extinction event disappeared, never to be seen again. The End Ordovician, the first one, the End Ordovician event occurred 443.8 million years, that's plus or minus 1.5 million years, when climate went crazy with extreme temperature swings and intense glaciation in a large part due to the presence of an enormous continent sitting over the South Pole. 85% of all species disappeared. The next extinction occurred about 60 million years later at the end of the Devonian period. There may have been as many as 7 extinction pulses, each lasting a few million years. The causes were many and varied, but included in this mix was an extreme reduction in the level of oxygen in the atmosphere. The End-Permian extinction occurred beginning about 251.9 billion years ago, plus or minus 31,000 years. We're getting pretty precise here. It is colloquially referred to as the Great Dying. It is the Earth's most severe extinction event, with up to 96% of all marine species and 70% of all terrestrial vertebrate species becoming extinct. Most likely causes are attributed to the rapid deposition of the Earth's biggest large igneous province, a 720,000 cubic mile pile of lava and other volcanic rocks, referred to as the Siberian Traps. The eruptions themselves, combined with the cooking of older coal deposits, resulted in elevated carbon dioxide and methane in the atmosphere. And here's a flow chart showing the effects of this massive eruption, including global warming, oxygen depletion, acid rain, and ocean acidification. It has generally been accepted that the Siberian Traps formed in as little as 600,000 years. A hot time there. But the new timescale developed at MIT, based on more precise dating techniques, is developed on more precise and indicates that the most severe extinction in history may have happened more than 10 times faster than the scientists had previously thought, and may have taken only 60,000 years, or give or take 48,000 years, to do its dirty work, practically instantaneous from a geologic perspective. The extinction event number 4 occurred at the end of the Triassic period. The supercontinent of Pangaea, which contained all the future modern continents into a single landmass, began to rift apart. And as North America separated from Africa and the Atlantic Ocean began to open, volcanic activity on a massive scale again sent abundant carbon dioxide into the atmosphere. This led to global warming and changes to the oceans that were similar to what had occurred in the End-Permian extinction. Close to home, the Palisade Sill on the Hudson River, a 60-kilometer long intrusion, is part of these eruptions as Pangaea broke up and the present configuration of the continents took shape. Now, the most recent mass extinction is the most famous because of which animals left the stage. It is the one that defines the boundary between the Cretaceous and the Tertiary periods. This timeline, formerly known as the KT extinction, where K stands for Cretaceous, which refers to the common presence there of chalk, and the T stood for Tertiary. This boundary is now known as the KPG extinction because sediments deposited after the end of the Cretaceous period are the start of the Paleogene period. So excuse me if during this talk a KT slips in. Scientists investigating the cause of the end of the Cretaceous extinction that wiped out 70% of life on Earth generally fall into 2 camps. One group blaming it primarily on an extraterrestrial impact, which initiated massive volcanic eruptions, while others give the igneous activity top billing and view the extraterrestrial impact as coincidental. Although there was a massive die-off of most life forms, two major groups of animals to succumb were the dinosaurs and the ammonites. You know the dinosaurs. Our knowledge of these beasts, their size, distribution, appearance, and behavior increases every day. We now know that at least some species had feathers, and some had large hollow crests with which to give them a greater voice during courtship. It would really have been nice to observe these magnificent beasts on the hoof, assuming they conform to rules directing social distancing. Now, they have disappeared from both land and sea, and from the sky, exiting with them were the pterodactyls. That whole group was those magnificent non-dinosaur flying reptiles. If the dominant inhabitants leading up to the fifth extinction had politically divisive attitudes, not unlike what we have today, you probably could have seen cartoons like this. I'll let you absorb that for a minute. Okay, thank you. I won't over. Oh. But from the Cretaceous Surgeon General, there's another explanation.
It was smoking.
They were smoking.
Oh.
In terms of evolutionary success, ammonites deserve a posthumous award. Ammonites were mollusks like squids and octopus. The only shelled representatives I have today is the nautilus. They produced magnificent shells that were engineering marvels, enabling them to submerge in the oceans to great depths. The specimen shown here, which we picked up along the Jurassic coast in southern England, is shown here. You're not seeing his shell, but you're seeing filled interior chambers. The crenulated septa were added as the animal grew, and this delicate buttressing gave them great strength with a minimum of added weight. The ammonites first appeared in the Paleozoic, survived the deadly End-Permian extinction. Then 96% of all species died, and when 96% of all species died at the end of the Cretaceous, then expired at the end of the Cretaceous 330 million years after they first appeared on Earth. Studies have shown that the environment at the end of the Cretaceous was becoming somewhat less hospitable for many life forms, as illustrated here by the diminishing population and variety of single-celled foraminifera. This environmental degradation, largely due to the effects of extensive volcanism, was just a shadow of what loomed over the horizon. Now, why did all of these forms that were doing so well on land and in the sea die out? Well, as you know, there is a basic disconnect between the view of secularists who view the Earth as being billions of years old and creationists who view the calculations of Bishop James Ussher, who calculated the cosmos to have been created starting at 6 p.m. on October 22nd, 4004 BC, and the year of the deluge as 1656 years after creation, or 2348 years ago. Secularists refer to these dates as BCE, before the Common Era, rather than BC. Ideas as to why the dinosaurs are no longer amongst us are in stark contrast, depending upon whether you seek the answers in the realm of scientific research or in the Bible. Creationists have stated that are always questioning whatever the scientists do, and they said that among evolutionary scientists, there is no consensus of opinion with respect to why the dinosaurs died out, why they disappeared. Now, scientists have come up with two ideas, and I think we've got a pretty good handle on what's going on, as we shall see. Recent research, as we shall see, all right, Recent research, as we shall see, gives us a minute-by-minute, hour-by-hour, and day-by-day accounting of when all hell broke loose. The creationist community itself is decidedly disunited in its treatment of dinosaur demise. Bible literalists have proposed a number of possible answers to the life and death of the dinosaurs. As reported in the National Geographic, quote, the Bible does not specifically say what happened to the dinosaurs, but allows for a number of possibilities, unquote. The possibilities include the following. The dinosaurs perished before humans existed. And for some creationists, this would not work because there was no death until after Adam ate the apple. Their death, bloodshed, disease, and suffering were a result of Adam's sin. Or they died after the fall, but before the flood. They perished in a universal flood. They survived a geographically local flood, and then died. Or were taken on board the ark and then became extinct after the flood, or something like that. On a lighter note, there also could have been warfare between dinosaurs and mammals on the arks, plural, or they simply just missed the boat. Thank you, Gary Larson. We have also seen an assortment of human-dinosaur interactions from the entertainment community. The diorama at the bottom is from the Creation Museum in Petersburg, Kentucky. Speaking of floods, the museum recently filed a claim with their insurance company for water damage. Late in the autumn of 1680, the Earth was visited by a comet so bright that it was reportedly visible even in daytime, and it was noted for its spectacularly long tail. Isaac Newton observed the comet, and his calculations of the trajectory confirmed his universal theory of gravity. The comet inspired one of Newton's closest colleagues, the mathematician William Whiston. As was the prevailing belief back then, and for many now, Whiston believed that the Bible was a true historical account, and it was up to modern thinkers to find the scientific explanation for miraculous events in the Bible. Edmund Halley, in viewing this comet, suggested that the comet passed by the Earth every 575 years. Cutting backwards, Whiston determined that one encounter occurred at 2342 BC, which coincidentally was very close to Usher's date for the Great Deluge. He felt that the gravitational pull of the comet fractured the Earth's crust, and the tail of the comet saturated the atmosphere, leading to the cataclysmic flood-producing rainfall. In 2012, Dr. Andrew Snelling of Answers in Genesis resurrected that concept, stating that geologists are uncovering mounting evidence of asteroids and meteorites that struck the Earth during the past, and asked if these extraterrestrial missiles could somehow be related to the initiation of the flood. Snelling stated that one example of an impact powerful enough to trigger the flood is the Akram impact crater in South Australia. This article, as with the other reports from Answers in Genesis, is a jumble of misapplied scientific information and fails to acknowledge the fact that the crater in Australia is 580 million years old. Now, given the age of the Earth is expressed in hundreds of millions of years, I'm not sure how you would describe extraterrestrial visitations. Are their appearances frequent or infrequent? As of 2017, researchers have been able to identify 190 impact structures of various sizes and ages, but the true number of craters is clearly an understatement, as erosional and depositional processes tend to hide or erase older impact sites. Some examples here. A meteorite crashed into what would become in the Chesapeake Bay about 35 million years ago. The crater, when formed, was 85 kilometers across. The most well-known and readily recognizable crater is the Barrington Meteor crater in northern Arizona. It was formed 49,000 years ago by an asteroid between 30 and 50 meters in diameter. In 1908, the Tunguska Event, the Tunguska asteroid, exploded over northern Siberia, flattening approximately 80 million trees. Not far from there, and only 7 years ago, a meteor or comet entered Earth's atmosphere over Russia. It was calculated to have been approximately 66 feet in diameter and passed through the upper atmosphere at about 40,000 miles per hour. Now, in case you're wondering when we will be visited next, Christian writer Thomas Horn predicted that the next meteorite would be arriving in 2029, and the Bible proves it. Amazing. Back on Earth, geologists discovered that for reasons unknown, magnetic reversals were frequent, on the average about every 500,000 years. When this occurs, what is north becomes south, and what's south becomes north. Only your compass knows for sure. But all rocks of a certain age show the same magnetic polarity, either normal or reversed. Geologic sections from around the world have been correlated using the records of polar change, of magnetic change and polarity change. In the 1960s, analysis of the magnetic reversal patterns in rocks from the seafloor showed that sections of the floor on one side of the Mid-Atlantic Ridge, the Mid-Atlantic Deep Sea Ridge, exactly matched the pattern on the other side. The ships going across all of the oceans, tugging small magnetic reading devices behind them. And the patterns on one side matched what was going on the other. And this proved that seafloor was being created along these mid-ocean ridges, and that continents were not stable in their positions, but were moving away from each other. If you go to the hills near Schuylerville, you'll see pillow basalts. These are rocks formed on a mid-ocean ridge when lava was extruded to build new oceanic crust. Now, the ocean floor magnetic striping validated the theory of continental drift, now referred to as plate tectonics. Back in 1912, a German scientist, Alfred Wegener, studying the shorelines of opposite continents, had proposed a theory that continents had moved with respect to each other. As with many great ideas, his idea was soundly denounced and lay dormant until the production of paleomagnetic surveys and maps, which proved him right. Now, in order for the new magnetic timescale to be used to date rocks, it had to be tied into the standard geologic timescale, which had been built up through the decades based on diagnostic microfossils contained in sedimentary rocks and radiometric dating of igneous rocks. Dr. Walter Alvarez of Columbia University's Lamont Doherty Geological Observatory began studying crustal movements around the Mediterranean. Walter is the younger of the two men in this picture. That's his father, Luis, an experimental physicist on the left. Alvarez the younger was sampling the exposed strata and to measure the paleomagnetic orientation preserved in these deep sea limestones, now exposed at the surface. Now, in the field, you can easily tell where someone has sampled for this data. Clusters of 1-inch diameter holes drilled into the rocks, making the exposure often look like Swiss cheese. Using microfossils, Alvarez and his colleagues were able to date the reversals for an interval of more than 100 million years. The Cretaceous-Paleogene Boundary in the rocks at Rubio Gorge near Gubbio in central Italy could be spotted just with the naked eye. The lighter limestone below the boundary is rich in sand-sized forams, that's short for the foraminifera, while in the red limestone above the boundary, the dominant species that had been low were all gone, replaced by a much smaller foram with the awkward name, which I will not burden you with. Clearly, at this boundary, something had happened. Something or some things killed off essentially all of the forams that had been deposited in the lower unit. Exactly at the boundary where between the two limestones lies a 1 centimeter thick layer of reddish clay without fossils in it. In the photo here, Luis's hand rests on the limestone above the boundary. Walter Alvarez's fingertips rest on the boundary layer itself. Walter showed his father a polished specimen from Rubio that included a portion of the upper and lower limestones and the reddish clay between. He showed it to his father and explained that it captured the time of the great mass extinction and represented the time when not only most forams died, but the dinosaurs as well. Although most non-geologists viewing this chunk of rock would have registered at most a polite curiosity, Luis Alvarez commented that his son's description was one of the most fascinating revelations he had ever seen. He postulated that the clay layer represented a period when no microfossils were part of the sediment that rained down onto the seafloor 66 million years ago. But the question was why? He estimated that the thin clay layer might represent, maybe 500,000 years of sedimentation. They performed detailed chemical analysis of the clay to see if there was some signal in the clay that could contribute some information. One element stood out. When the Earth was formed, iridium, like other elements of the platinum group, accompanied iron into the molten core, leaving these elements very rare in the Earth's crust. Their abundance in meteorites and the average material of the solar system is many times higher. The iridium found in sedimentary rocks is often too scarce to be detected. It is believed that the iridium settles from space in a steady rain of microscopic fragments, a kind of cosmic dust from thin meteors and comets that form the shooting stars that flame out high above the Earth. This heavenly rain falls to Earth where it is incorporated into the muds that accumulate on the seafloor, which eventually harden into rock. Now, measuring the expected low levels of iridium in the samples required a research nuclear reactor to apply a technique called neutron activation analysis for making precise measurements of very low elemental abundances, as low as parts per trillion. One must exhibit extreme care when handling samples for analysis, wearing surgical gloves, as we do now, to avoid contracting the coronavirus. You don't want your samples to catch iridium from your gold or platinum jewelry to give it a false reading. Samples from the upper and lower limestones had predictably very low iridium readings. However, the samples from the boundary clay revealed an earth-shaking surprise. Iridium was 30 times higher. It was conjectured that the difference in the iridium content between the clay layer and the limestones could be due to the fact that iridium and the clays in the limestone sections were being diluted by all of the fossils. But there were thin clay lenses within the limestones, both above and below the boundary, and they also had very low iridium content. Thinking that possibly this anomalous iridium distribution was unique to the section they were studying in Italy, they went to the cliffs south of Copenhagen, which had a clay layer similar to what they had seen in Italy. When samples from the exposure at Stevens Klint on the Danish island of Zealand were examined, the analysis showed it to be 160 times more abundant than the limestones above and below. In a more recent publication, geologists reported that they found in Wyoming a claystone that contains 1,000 times more iridium than the limestones above and below. Further research found this iridium anomaly occurring just about everywhere else on the planet. Now, all sorts of ideas were put forth to explain the iridium spike in the end Cretaceous terminal event. Since iridium is many times more common in meteorites and in the solar system in general than on the Earth's crust, Walter and Luis began considering extraterrestrial sources for the iridium abundance. The first idea they pursued was that there may have been an exploding galaxy with blasted material throughout the galaxy. However, the tests of other diagnostic rare elements and isotopes in the clays came up empty, so they had to abandon the supernova theory. Now, the size of the apparent meteor or comet clearly cannot be measured. But if the same amount of iridium that was found at Rubio had been deposited in a layer around the Earth, which calculates out to about 200,000 tons of that rare metal, given the average iridium content of meteorites, they figured that the meteorite or comet would have had to have been 10 kilometers, about 6 miles, in diameter. Now we're talking about a rock the height of Mount Everest. And considering the driving force for the end Cretaceous extinction event, the Alvarez impact theory consisted of 2 parts. First, that a meteorite or asteroid struck the Earth 65 million years ago. And second, that changes on the surface were so severe that they led to the Cretaceous-Paleogene mass extinction. One approach to visualize the impact effects was to look at computer models used by the late Carl Sagan to see the conditions inherited in a nuclear war, the nuclear winter. A nuclear war between the United States and the Soviet Union would throw enough dust, smoke, and soot into the atmosphere to block sunlight for several months, lowering temperatures by tens of degrees and reducing solar penetration, halting photosynthesis, destroying plant life, and disrupting the food chain. The ozone layer might also be affected, allowing the sun's ultraviolet radiation to penetrate and cause further damage. In comparison to a nuclear war, we're talking, in this case, about an explosion with 7 billion times as much force and energy as the bomb that was dropped on Hiroshima or Nagasaki. So it's clear that at that point, that Earth took a massive hit. But where is the wound? Where is the crater? Remember, we're looking for evidence that is about 66 million years old. The start of a successful hunt was a discovery in southern Haiti of a thick sequence of deposits left behind a tsunami, a non-tidal wave. Because the deposit was so thick, far thicker than any other previously measured in a Cretaceous boundary section, it was deduced that the impact had to have occurred in the Gulf of Mexico or in the Caribbean area. The deposits were a jungle of angular fragments from all sorts of rock types, with each class containing large amounts of shocked quartz. Shocked quartz is a very common hard mineral, but when shocked, displays microscopic defects in the crystal structure produced by the passage of high velocity, high pressure shock waves. There were also abundant spheres of fused volcanic glass, some as large as 8 millimeters in diameter, and angular volcanic glass shards altered to clay. Both the spherules and the shocked quartz grains unambiguously indicate that the deposit was ejected from an impact crater. More recently, end Cretaceous deposits have been identified around the Gulf, and microtektites have been detected on land and in deep sea cores from around the world. The colors here reflect the size and abundance of the impact ejecta and suggest the distance from an impact site. Samples in all of the sites have elevated iridium levels. The red dots, the yellow dots at sea represent samples collected during cruises as part of the deep sea drilling project. I was on one of those cruises as we cored the seafloor off the coast of Northwest Africa. One article documents the presence of tsunami deposits in southern Chile, practically at the south end of South America. There was a shallow seaway that extended down from the Gulf, and the tsunami worked its way down there in not too long. But within the Gulf of Mexico, where did it hit? In the search for oil and gas deposits, gravity mapping had begun on the Yucatan Peninsula in the 1940s. In the late 70s, Glenn Penfield, a 26-year-old field geophysicist, was at work interpreting gravity data collected from the waters offshore the peninsula. He's a lot older in this picture than when he was doing his work. Quote, when I laid the onshore gravity map next to my #2 pencil mapping of the adjacent offshore magnetic anomaly, the fit was perfect. It was also unlike any volcanic structure. There's the site of the impact, and here you can see the crater straddling the present edge of the Yucatan Peninsula. The onshore deposits, the onshore buried rim of the crater reflects the groundwater flow. That's the area south of that black line. The onshore buried rim of the crater reflects the onshore buried rim of the crater affects the groundwater flow around on the peninsula, and it directs groundwater around the crater, forming a necklace of water-filled sinkholes, commonly so referred to as, I guess, if my Spanish is good, centes. Upon seeing all this, the press went wild. Alvarez theory on dinosaur die-out upheld. Experts find asteroid guilty of killing the dinosaurs. As I mentioned, the environment toward the end of the Cretaceous was getting a bit dicey for many life forms. The decline in the diversity of foraminifera, as shown previously, illustrates the response of the surface-dwelling single-celled animals to climate deterioration. These fluctuations in Earth temperature and changes in ocean and atmospheric composition are generally attributed to the emplacement of the massive Deccan traps on a land which is now a large portion of Western India, before and during the End Cretaceous Event. The impact likely triggered the most intense eruptions of lava on the Deccan traps, as illustrated by the unconformably close coincidence between the most intense eruptions and the date of impact. Earthquakes generated by the impact would have been quite forceful, even on the opposite side of the planet. As one geophysicist put it, there can't be a magnitude 12 earthquake because the elastic strain of the Earth's crust couldn't handle that energy. But with a hit this size, all bets are off. At impact, the Earth rang like a bell, triggering volcanic eruptions around the globe, which may have helped contribute to the devastation. Excuse me. The asteroid itself was so large that even at the moment of impact, the top was probably higher than Mount Everest. In its nearly instantaneous descent, it's calculated it took 5 seconds to pass through the atmosphere. One researcher modeling the comet trajectory calculated that if it had come in on a low trajectory across the Atlantic Ocean, it would have crossed the Atlantic in 4 minutes. It compressed the air below it so violently that it briefly became several times hotter than the surface of the sun. The pressure of that atmosphere in front of the asteroid started evacuating the crater even before it got there. And when the meteorite where the meteorite or asteroid touched ground zero, it was totally impacted. It was so massive the atmosphere hadn't even made a scratch on it. Now I have to make an apology here. Some of the illustrations, as well as the title of this talk, are an error, coming at the Earth at a speed between 40 and 43,000 miles an hour. They wouldn't have seen it coming, at least if you're a dinosaur. As the asteroid collided with the Earth in the sky above where there should have been air, the rock had punched a hole of outer space into the atmosphere as the heavens rushed in to close this hole. Enormous volumes of Earth were expelled into orbit and beyond, all within a second or two of impact.
Wow.
The fireball, well, this is an artist reconstruction. The fireball of the Yucatan impact overwhelmed the atmosphere, blowing right through the entire blanket of air, expanding and accelerating out into space, and launching particles of the Earth in trajectories which carried them far around the Earth before they fell back to the ground. One researcher suggested that there were probably little bits of dinosaur bone on the moon. And still the fireworks continued, even as the scorched fireball of rock vapor blew away into outer space. It was followed by a second fireball, not as hot, but almost as dramatic, for about 3 kilometers down from the surface on the Yucatan Peninsula. The rocks are a thick layer of limestone. Limestone is nature's way of storing carbon dioxide gas. The limestone suddenly released its stored CO2, and at impact, enormous quantities of this gas almost instantaneously were released, like popping the cork on a colossal bottle of champagne. Animals living just over the horizon first witnessed a flash of light in the sky, then a last moment of calm. Then, as the ground began to shake uncontrollably from the passing seismic waves, the sky itself turned lethal. Extending out thousands of kilometers from the crater, the Earth's surface itself became an enormous broiler, cooking, charring, igniting the trees and animals that had not sheltered in some fashion. Enormous forests were ignited in continent-sized wildfires that swept across the land. One researcher has calculated that for as far as 800 kilometers from the impact point, the surface temperature reached 300 degrees Celsius. Celsius.
Wow.
Ejected particles fell to Earth in the lethal incandescent sky. The sky briefly turned to normal, but then the air was blackened by rising plumes of smoke and soot from fires from the consumed forests. The fires consumed much of the oxygen in the atmosphere, and seismic shaking on the coastal shelves triggered massive submarine slides. The combination of these slides and seismic waves triggered seismic waves triggered by a tsunami. The massive waves, perhaps the tsunami wave, perhaps a kilometer high, which spread throughout the Gulf of Mexico. Most of Mexico and the United States was reduced to a desolate wasteland. Rapid short-term cooling followed the impact as the Cretaceous-Paleogene Cretaceous-Paleogene Boundary, as easy for me to say. As stated in one report, for the first time to our knowledge, we can demonstrate unambiguously that the impact of the Cretaceous-Paleogene Boundary was followed by a so-called impact winter. The worldwide layer of soot found at the boundary was consistent with global fires. This soot caused near total darkness, shutting down photosynthesis and producing severe cooling at the surface and in the oceans. Here is data from one boundary section in New Zealand far away, showing elevated soot and iridium abundance. Some have suggested that after the return to light, the climate again went into the opposite extreme as high levels of greenhouse gases and water vapor persisted in the atmosphere. Water vapor from the impact was probably removed quickly from the atmosphere as rain, but the rain was a devastating rain, and this it was a devastating acid rain. This may have been sulfuric acid from the sulfur in the rocks that made up the peninsula. There was also nitric acid formed from the atmosphere itself. Finally, we come to the article that again brought to light for the general reading population this amazing period of Earth history, and which we just taught. The Tanis exposure in North Dakota is part of the heavily studied Hell Creek Formation, a group of rocks covering 4 states in North America, renowned for many significant fossil discoveries. The site was originally discovered in 2008 by University of North Georgia Professor Steve Nicholas and field paleontologist Rob Sula. Recognizing the unique nature of the site, they brought in Robert De Palma, a University of Kansas graduate student, to perform additional excavations. That's De Palma in the upper left. The site was systematically excavated over several years, beginning in 2012. De Palma's work was carried out in near total secrecy. Key findings were presented in 2 professional conferences in October 2017. The results of the field work in this portion of the Hell Creek Formation were widely covered in worldwide media in March of last year. The name bestowed on the site by De Palma, recalls Tanis recalls the ancient Egyptian city where a 19th century discovery helped unlock the secrets of the pyramid, of the hieroglyphics. In a sly nod to pop culture archaeology, Tanis was also the sand-engulfed city where Harrison Ford's Indiana Jones battled Nazi raiders for the lost Ark of the Covenant in the Oscar-winning 1981 movie. At Tanis, unlike any other fossil-rich site, circumstances allowed for the preservation of exquisite moment-by-moment details caused by the impact event. Findings include animals and plant material preserved in 3-dimensional detail and at times upright, rather than pressed flat as usual. Marine reptiles, fish, and invertebrates added to the mix, thrown together by the massive wave moments found together miles inland in what was interpreted to be a river valley. The sketch at lower left is one collection of those fish remains, seen at right in beautiful detail. There are abundant microtectites in the sediment and hundreds of fish remains, generally showing evidence of death by suffocation. The deposit has abundant microtectites embedded in the gills of more than 50% of the sturgeon and paddlefish carcasses within the deposit. Here we see the remains of a paddlefish with all those microtectites, and here the skeleton, the skull of a sturgeon. And you can see in great detail all of these rock grains in their gills. There are abundant microtectite holes in the soft riverbed mud, similar to these from an exposure in New Jersey. And also, there were microtectites preserved in amber on some of the tree tree trunks, some of which are in vertical position. Chemical analysis of these spherules matches that of other end Cretaceous deposits. They have also found large primitive feathers, 30 to 40 centimeters long, believed to have come from large dinosaurs. And the exposure itself is capped by this after the deposition of this iridium-rich clay. We do see a layer of what appears to have been mold, small fungi, and then above it we start getting ferns reappearing as life returns to the locality. The events at Tanis occurred far too soon after the impact to be caused by a tsunami. Instead, much faster seismic waves from the massive earthquakes probably reached the Hell Creek area as soon as 10 to 15 minutes after the impact, creating seiche waves between 10 and 100 meters, that's 33 to 330 feet high, in the western interior seaway. A seiche is a standing wave in an enclosed or partially enclosed body of water. The only experience with this phenomenon was in Albany about 6 years ago, while I was waiting to see my physical therapist on Western Avenue. There was a large fish tank in the waiting room, in which all of a sudden there were large craft warnings and some very confused fish. That was the results of an earthquake further down in, I guess it was Dutchess County. The waves of Tanis carried sea, land, and freshwater animals and plants and other debris several miles inland. The seiche deposits were deposited and covered the site twice, as millions of tiny droplets and debris from the impact were arriving on ballistic trajectories from the Yucatan Peninsula. De Palma's team said, you could say that all of this research paints a pretty picture unless you lived back then, but not everyone is in agreement. Some scientists questioned De Palma's interpretations and the top billing he gives to the asteroid impact. Capturing the event in such detail is pretty remarkable, concedes Blair Schoen, a geologist at Princeton University. But he says the site does not definitively prove that the impact event was the exclusive trigger of the mass extinction. Schoen and others believe environmental turmoil was caused initially by the creation of the Deccan traps. A driving force behind the pro-Deccan trap team is Dr. Gerda Keller, also of Princeton. Dr. Keller has a following. You can show support for her research and conclusions by purchasing online a tote bag or t-shirt. It has been hard for her to go against the asteroids hypothesis. As summarized in Blair Bosker's article in The Atlantic, researchers had proposed interesting and bizarre explanations for the dinosaurs' demise. We're not going to go into some of them are crazy. Now, these theories fell by the wayside when the Alvarez team announced their discovery in the journal Science. Mystery solved. An asteroid had crashed into the Earth. Their hypothesis quickly gained traction, and as in visions of killer space rocks, sparked even the dullest imaginations. But Keller and her Princeton group has endured decades of ridicule for arguing that the fifth extinction was caused not by an asteroid, but by a series of colossal volcanic eruptions, but she's reopened the debate. You might expect paleontologists to be cracking open the bottles of champagne, but in weeks since the astonishing find was announced, first in the New Yorker article and later in scientific publications, their outrage only grew louder. Many scientific journals reach out to journalists to cover a soon-to-be published paper, a fixed number of days before the paper will actually be published. And this has become known and gets known to the wider world. This period between the notice and the publication is called the embargo period. But every once in a while, some news publication breaks the embargo and publicizes a story and the paper behind it before the agreed time. Journals, understandably, don't take this well. The New Yorker committed a version of this mistake as well as hyping up the results, apparently with the encouragement of Dr. Palmer. De Palma. I'll close this talk speaking as a mammal that we are indebted to the KPG asteroid for it eliminated the dinosaurs and left room for our forebears to survive and prosper. The animal in this picture is a reconstruction, artist's conception of what a end Cretaceous mammal would have looked. No, it's not a squirrel. Although I wonder if the dinosaurs would have been kinder to the earth than we have been. Thank you.
Frank, I want to thank you for that. It was wonderful, very interesting and entertaining. But a question I have for you is that the theory of volcanic eruptions, has any research or any conjectures been done about where those volcanoes might have occurred?
They come up from below.
I mean, on the globe, on the square, their surface expression be.
Okay. The Deccan traps, like the Asian continent was fairly well intact back then, except for India, which was heading north at the end of the Cretaceous. In fact, when I was doing my doctoral thesis, my research, I was looking at a fairly long length of time from a number of localities, and what was nice about, since I was able to look at the nanofossils and identify simply a progression of populations that extended from high cold latitudes to more temperate latitudes closer to the equator. And I could see these changes in the rocks in one particular core, which was on the tail end of the plate that had India on it as it was heading north. So what probably happened is the chunk that became the Indian subcontinent crossed over a hotspot similar to the hotspots that we have that are creating the Hawaiian Islands. And when it got to that point, for some reason, which we will never know, all hell broke loose. So I mean, the amount of stuff that came out had to be truly amazing. We're talking about thousands of cubic miles of rock deposited both in the crust and on the surface in a very short period of time.
Okay, thank you. I have not seen anybody ask a chat question, so I'm going to unmute all, and if we can be kind to others, and if you have questions, please address it to Frank at this time.
Frank?
Yes.
Hi. Wouldn't it be asteroid strike and the volcano just complement each other in the destruction? Not one or the other?
They were,
They were in position in New York.
I think they would,
Contracting COVID-19. Dr. Good to see you. And
Don,
He has a radio on.
I have muted everybody because there was some extra noise coming through. Frank, I'm going to turn you back, unmute you here. Can you unmute yourself now?
okay. Can you hear me?
Yes. What was you were,
Judy, I think both effects had very had a similar effect on the air, on the atmosphere and the oceans. I don't think one would counteract the other.
Wouldn't
okay,
they complement
if
each other?
anybody, I unmute everyone again,
Yes,
but
they would
please
complement.
turn down any background noise.
people to make sure they're negative. Whereas the infection, this is regular PCR that we're doing for lots of people, but they test positive.
Somebody's got to.
Ma'am, turn off your TV in the background, whoever has that on, please.
How long did you kind of
We go back to muting all.
So actually, until I test negative, I'm hopeful that I actually can go and get a test tomorrow.
Okay, we're all muted unless you have a question. If you have a question, unmute yourself. If you have a question, unmute yourself and then address that question to Frank. Surely Frank, you did such a wonderful job. There's no questions.
I think I killed everybody in the audience.
Well, I will add that, you know, it's enlightening to learn that there are other things we have to worry about for existence besides a global pandemic.
Right.
Hi, I had another question.
Yes, Judy.
Hi. The May 2019 article that was referenced near the end, what was that about?
The May 19th, that was on the the discovery in North Dakota, the day the dinosaurs died.
Okay,
Oh, okay.
I see Roy Thornton has unmuted his
Thank you.
microphone.
Yes,
Roy, do you have a question?
I do. Frank, is there any fossil evidence of living creatures above that clay iridium layer?
They come back. Yes, it took them a while, and there were a couple species that did make it across the boundary. There were a number of the life that came back had to have been in as far, I guess, as far away from the impact point as they could be. Also, if they were marine organisms, they would have hopefully been in deeper water. I think they did some study, and with the animals that died out, and those fishes that made it across the boundary, those that were deeper water fishes survived, while others did not. Anything that was living close to the surface took a major hit.
Okay, Jonas,
And then life returned with the plants, formed a natural progression of molds growing on barren soil, eating whatever was there, and then ferns reestablishing the chain, and eventually you end up with trees.
okay, Jonas, I see you've unmuted. Do you have a question?
Yes, I have a question. What's the time this happened, Frank? What's the timeline? How many years this happened?
How long ago?
Yeah.
About 65.8 million years.
Okay, but at that time also all the continents were one piece.
Not at that time. They had started to split back a lot earlier, and I believe at one point they came back together, so that the pillow basalts that we have in Schuylerville are actually what was left of an earlier version of the Atlantic Ocean, where the continents came together and then they split apart again. So actually at Schuylerville, you're looking at deposits that were the seafloor. But once they split apart, the Cretaceous was still, the continents were moving, but they were relatively close to where they were now.
Oh, okay, thank you.
Okay, Kevin, I see you have your microphone open. Or do you unmuted? Do you have a question for Frank?
No, please mute it.
Okay. I'll mute you. Anybody else? Does anybody else have questions for Frank? Anybody else?
I have a question again. Where are
Yes.
you going for, where are you going for dinner?
What are you bringing?
Takeout.
Oh, okay.
I have a question.
Yes, Bill.
Is there any DNA evidence that exists before and after the event? Because one wonders how you reestablished mammals that, you know, in some ways are quite similar to dinosaurs. Was there a blueprint for how things came about again?
They had been studying mammals for some time during the Cretaceous, watching them develop, but they never really took hold. Some artists have sketched T-Rexes and similar large carnivorous dinosaurs raiding mammal burrows and eating the young or something like that. They were slowly developing during the Cretaceous. De Palma actually on the site in North Dakota says he's found what was probably a burrow in the deposit with remains of an early mammal in it. But I don't think they could do DNA, but simply looked at the skeletons, they could see how they progressed across the boundary and developed from there. All hard parts. We're not doing any cloning.
Anybody else have questions for Frank or anything else? If you do, unmute yourself and go ahead.
Don,
Yes.
I don't have a question. I just want to comment that the Schuylerville area that Frank was talking about is where David's father owned it's a Stark Snob. He owned the land there. His farm was actually there.
Okay.
That's all.
Thank you.
Thank you. Anyone else have any questions or comments?
Well, may I speak?
Yes.
Thank you all for coming. Put your chairs back where they go. If you'd like to meet,
Thank you, Frank.
if you'd like to meet in person, we're going to be picking up food from Celadon Thai for dinner. We can meet out in the parking lot.
Oh, no.
Thank you, Frank.
Thank you, Frank.
Yes. Thank you all for coming and participating. We do appreciate it.